theory, a view that the universe is always expanding but maintaining a constant average density, with matter being continuously created to form new stars and galaxies at the same rate that old ones become unobservable as a consequence of their increasing distance and velocity of recession. In cosmology, the steady-state model is an alternative to the Big Bang theory of evolution of the universe.
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Good afternoon, everyone. Have you ever wondered how the universe was made, or even just the Earth itself? We always hear the word universe, and every time we hear it, the word all comes to our minds. But before everything, what does the universe even mean? Where does the word even came from? In basic words, universe is everything you can touch, feel, sense, measure, or detect. Did you get it? Well, let me elaborate it for you. The universe includes all the living things: planets, stars, galaxies, light, and everything that you can think of. Imagine living beings lasting for millions or even billions years, but come and think of it deeper. Even the stars cannot even live forever. Planets may collapse soon and everybody just dies. Life is not a substance. Now we have two goals in front of us. One will be explaining the story of our universe and why we all think it is true. As I've said a while ago, everybody just dies. The universe die too? Does it have beginning and end? We'll discuss to you the theory named steady state. Now, what does this theory mean? If we are going to find the definition of the internet, it will say that our universe has no beginning or end. This theory is the understanding that the universe is constantly creating matter, expanding over a period of time, and maintaining a constant average density. Naiisip niyo na ba kung papaano nabuo ang teoryang ito? Sino ba sa tingin ninyo ang gumawa o nakapag-isip nito? The theory was developed way back 1924 na binuo ni Fred Hoyle, Thomas Gold, and Hermann Bunge. They came up with the idea of the universe isn't changing in time and uniform of space. Now, papaano nag-expand ang ating universe, but it is unchanging. Here comes the perfect cosmological principle. Ano nga ba ang ibig sabihin nito? This principle states that the universe is homogeneous and isotropic in space and time. What does this mean? To understand it more, let's watch a short clip from the testimony of one of the pioneers of steady-state theory.
Hello, my name is Fred Hoyle. I was born on June 24th, 1915 in Bingley, Yorkshire, England, and I am a British astronomer. In the 1950s, I was the champion of one of the two hypotheses, which is the steady state theory. Join me as I look back on my journey of how we developed this theory. My interest in astrophysics began thanks to the influence of my friend and colleague Raymond Littleton, who persuaded me to focus on it instead of pure mathematical physics. I met Hermann Bunge, Austrian-born British mathematician and cosmologist, born on November 1st, 1919, in Vienna, Austria, and Thomas Gold, Austrian-born British astronomer, born on May 22nd, 1920, also in Vienna, Austria, while I was involved on radar during World War II. We used to talk about astronomy in our spare time, and after seeing the movie Dead of Night, we came with the concept of steady-state theory. In our theory, we propose that the cosmos is constantly expanding while maintaining a constant average density. It states that the universe will always look the same as it does now. It recommends that old and new galaxies be blended together in space, and that there should be none background microwave radiation. We expounded this theory of cosmology in 1948 in order to counter the idea of Big Bang, which was actually a nickname that came from me. In Albert Einstein's equations, I included a negative pressure C field, the cosmological principle, which states that the cosmos would fundamentally seem the same no matter which way you look at it. And my idea was already widely accepted at the time. It was called the perfect cosmological principle, and it states that there are never Big Bangs, no moment of creation, and thus no creator.
While teacher Lance talk about how steady-state theory was originated and evolved, I will be explaining the other side of the steady-state theory, which involves the evidences against it. I am Althea Miguel, and welcome to our lesson that outlines about the different criticisms, strengths, and weaknesses of the steady-state theory. Have you had any idea on when did evidences against steady-state theory began to emerge? Well, if not, it started in 1960s. There are at least 3 observations that emerged that time. The radio telescope observation, the discovery of quasars, and the cosmic microwave background. The radio telescope observation discovered that billion years ago, there were more cosmic radio sources than there are presently. This would imply that cosmos is changing throughout time, which would be in direct opposition to the hypothesis. While the discovery of quasars frighten things, although extremely tiny, can only be seen from a considerable distance away. They emitted billions of light years of light. The fact that quasars have only been discovered in the early cosmos is compelling evidence that the universe has evolved through time. And lastly, cosmic microwave background is a faint background radiation that pervades the entire space and is identical in all directions. The genesis of this radiation is almost hard to explain in the steady-state paradigm. To elaborate the different strengths and weaknesses of the steady-state theory, let's watch another clip.
The great Herman Bond here. What's up? And we will talk about the strengths of steady-state theory, which me and my bros formulated. There are a number of problems with the steady-state theory, but at the time the theory was proposed, there were also points in its favor. The steady-state theory rests on the foundation of the perfect cosmological principle. The advantage of the steady-state theory over some other theories is its simple and aesthetic explanations of certain troublesome topics. For example, since the universe is unchanging throughout the time, the universe needs no convoluted explanation of its beginning. The steady-state theory provided straightforward explanations for how the cosmos worked, but although astronomers discovered discrepancies in the idea when observatories went further back into the universe's early ages, some still think that the background radiation is the result of a huge number of radio emitters that are too feeble to be detected separately. This method necessitates the existence of around 100 trillion such sources, which is nearly 10,000 times the number of observed galaxies that are gone million as luminous as the rigid sources we detect today. Sadly, only a small number of astronomers are ready to go such lengths to save the steady-state theory.
Here's for further details about the weaknesses of steady-state theory. The existence of quasars as well as the variation in the expansion rate of the cosmos a few billion years ago is proof that the universe is not in a stable state. When the steady-state theory was first proposed in 1948, there was no evidence for the evolution of the universe. By the mid-1960s, it had become part of the growing body of data stack against the steady-state theory. Objections are raised against the steady-state theory as it violates of one of the fundamental laws of physics as the law is currently understood. The law of conservation of matter and energy states that the matter and energy are interchangeable and can change between forms, but the total amount of matter and energy in the universe must remain constant. It can be neither created nor destroyed. The steady-state theory requires continuous creation of matter in violation of this law. What is the future of the universe? Will the universe continue to expand, or will it eventually contract because of the gravity? To answer this, it is said that the end can be determined in two factors. We may anticipate the universe to expand indefinitely and then cool off since all galaxies are moving away. And gravity, on the other hand, is trying to slow down the expansion by pulling objects together. The universe's fate is a delicate balance between these two. If the expansion succeeds, everything would continue to expand indefinitely. If gravity triumphs, the expansion of the universe would come to a halt, and the universe would collapse. To assist answer this issue, astronomers are trying to figure out how much mass there is in the universe. The more mass there is, the more probable gravity will win.
I hope you learned something today, especially about the steady-state theory. Till next discussion, see you!